Hello everyone. Today we are going to learn about data structure stack. What is a stack? Stack is a collection of elements or data in a format where last inserted item will be first out. It has few important features like push, pop, pick. Push means insert data to stack. Pop means remove data from the stack. Pick means fetch data from the stack but don't remove the top element. So let's discuss with the help of a small diagram. Here I'm trying to draw a stack structure. Okay, so this is kind of a stack. It is a collection of data where we store data. So first feature of stack is push. Push means inserting element to the stack. So when we insert data, it inserted like this format. So we insert here a. It will be denoted as top. Okay, so if I insert another element, say b, then top element will be b. Similarly, we can insert c and d, so the top element now becomes d. Okay, so this is the push feature. What is pop? Pop means removing data from the stack. So what does it mean? When we remove a data from a stack, it will be removed from the top. Okay, so the top element here in this stack is d. So when we remove, say, pop, then data is removed, which is d. Now top will be moved from d to the last element, which is c now. So the top becomes c. Okay, similarly, when we move again, pop again another element, it will be remove c, the top becomes p, and then a. This is the pop feature. Now what is a peek? Peek means fetch the top data from the stack. Fetch, now we fetch the data. Okay, when we say fetch, now suppose c is the last element or the top element. When we say peek, means we are removing, we are not removing the data, but we are only reading the top element. So the top will remain still the c, and when we try to remove or pop, now again after peak we will do pop, then c element will be popped even though we already picked it. Okay, so these are the basic features of stacks, where the first element inserted is moved to the bottom and another one inserted will move up, up and up again. So the top element keeps on going from here to here, from a to b, then b to c, and then finally the last element. So let's move on to the code and see how we can implement it into the C sharp. So as you can see, I have written a basic program for the stack implementation, where we have implementation for stack, and here is a node class. Node means storing of data and a link to the next node. So it is used in the linked list. So I am referring this here as well. We have A as a data, but this complete box is called node. Another box is B. B is the data, but inside which box it is called node. So nodes are a kind of a linked list elements which links to each other. So A is linked to B, B is linked to C in this fashion. Okay, so when we say next element of B, which is A. Okay, so now jump to the code again. Let's move to stack. Here we have two properties, size and node as top. Size we are not considering it as of now. we are talking about node here. So node is basic element which we just talked about. We are using it for storing data and link to the another nodes for the stack implementation. So let's implement first operation, which is push. As discussed, the push means insertion of data. What is data? Data is inserted into the input parameters. Here we are providing input parameter, the data, and creating a new node and assigning the data to its new node data. And the next element of this new node will be the current top of the stack, now which is null as of now in the start of the node, so it will be assigned as null, but the new top will be the new node. Okay, so this way we implement the push operation of the stack. Let's move to the next operation, which is pop. Pop means we are removing the data from the top of the stack, so we have to check if the top element or stack is empty or not. So we are doing it by checking top is null or not. Next we have to identify the data and return it from the pop operation, but we also have to move the top to the next element of the top, so that if we have any element available, then it will be next to it. So this is the operation of the pop. Now move to the next operation, which is peek. Peek means we have to retrieve the top element but not remove it. So we are simply checking again if the top is not null or null. So if it is, that means it is an empty stack. Otherwise, we will just simply return the data from this operation. So for this particular basic implementation, we have implemented some of these operations and try to check how our stack is working. So I created a new instance of the stack. I pushed some of the elements A, B, and C. So in this fashion, A and then B and then C. So top element will be C. Now if I do a peek, which will not remove but still return the element at the top, so I will get C. Again, if I do pop, still the top is C, so I will get C. And if I do again pop, then I will return B. And if I do peek again, which is the remaining element in the stack, is A. So let's run this. Okay, so you can see it's a stack implementation which I consoled at line 42. Then 46 to 48 I do the push. Then I pick the element at line 50. The peak element is C because C is the top element. Now again, if I do pop two times, that is C, B, and finally pick is A. So our stack is working perfectly fine. So I hope you learned something from today's lesson, and if you do, please like, subscribe, and share. Thank you and happy learning.